Hello everyone, hope everyone is doing well. If you have interest in computer vision and the pattern recognition along with the generative adversarial networks or the GAN, you must have seen some of these very encouraging and fascinating examples of taking 2D images and converting them to 3D objects. Like this example or this one, and this example as well, and there are many more examples like these. The results you have just seen, they are coming out from a very interesting project named EG3D or Efficient Geometry-aware 3D Generative Adversarial Networks. So if you are interested to use the models generated by EG3D project and learn more about these projects as well as how everything works, this video is for you. We will start our video by cloning the EG3D GitHub repo at my local machine running Ubuntu 20.04 with various Nvidia CuDA related libraries such as CuDA neural networks and the latest CuDA runtime 11.7. Next, we had to build our Python environment so we could use the code as well as the various model generated through EG3D project. Once environment is ready, the next step is to download various pre-built EG3D models which are built by using very popular face as well as the various images. EG3D comes with a visualizer tool. So next step is to load different pre-built models and analyze different shapes and learn the capabilities are available within the EG3D source code to generate the shapes or the 3D shapes from the single image or the single face shot. In this section, we are going to load all three different pre-built models. After spending significant time with visualizer tool, we will also export some of these faces as well as the shapes or the 3D shapes in the form of MRC file, and these MRC files will be loaded into application called ChimeraX, where you could load these 3D shapes and generate various surface-based results by using mesh or by using volume or the vertices, etc. The content covered in this video is really very hands-on, which you could follow in your own machine as well while watching this video. So let's get ourselves started. The main website for the EG3D project is here, and the source code for this project is available at this EG3D repo, which is part of Nvidia Labs. The full source code is available to perform training by using some of the very popular datasets. Here is my machine, and as you could see that I am running Ubuntu 22.04 and it's using the 5.18.6 kernel, and the GPU I have in this machine is Nvidia Titan XP. And here is the output of Nvidia SMI command, which shows that I am running CuDA 11.7 with my Nvidia display driver version at 515.57, which is quite relatively new. So I'm at my own machine and I have created this folder called EG3D Home. That's where I am going to work on this EG3D project. So first thing first, we can clone it. So here we are cloning the EG3D repo, and as you could see here is that the code itself comes with this environment.yml file, which can create a new environment for you. So let's take a look at this environment.yml to see the environment for the EG3D project. So we have already cloned the repo, so we can look into, and environment is here. As you could see that this environment is using Python 3.8 or above, PyTorch with Nvidia channel, Python libraries related to computer vision and the CuDA toolkit. So just wanted to let you know that I already have an environment. So if I show you Conda, and this environment, as you could see that Conda environment is active, it is running Python 3.9.12 as well as looking into the Python, and you could see that the TensorFlow is working and the GPU is enabled. Torch, here you could see that CuDA is available as well as the JAX, the version 3.14 is installed, and this version also supports the GPU devices ID0. It means that the environment which I have here is already has most of the component required for us to try the EG3D project, and that's the reason I am not creating a new environment for myself. One test, what you could do is that you could run this visualizer, because this visualizer is the important application where you could load the pre-built models and visualize them. And in order to get the pre-built models, you would need to access this page where all of these models are listed, which you could download from this Nvidia website. This website has all these models available, and by selecting this browser link, you will be able to download all of these models. And I have already downloaded these models at my local machine. So these models which are listed here, downloaded at my local machine, I will download them in my models folder, which I have just created. And all of these models are available. So looking into the file system, here is the models folder and all of these models are available. Let's come back. Now we will run the visualizer.py using Python. So Python visualizer.py, and this application has started. If you are launching this application and you have certain problems, you would have to solve that problems specific to your machine, because in order to use this application you need to have all the underneath requirements working, such as you need to have the CuDA lib working, CuDA neural networks libraries should work properly, and various other Python packages are required in order to make this code work. As you could see that the visualizer application which we have just launched is actually accessed here Nvidia GPU. That the application which we are going to use is definitely going to use the GPU memory. So first thing is we are going to load the model which is related with AFHQ 512. So I will be selecting this model and dragging and dropping it at this place. Once this model is dropped into visualizer UI, as you could see that this model is loaded, and looking at our command line, you could see that this model has been loaded and PyTorch plugins which are used to render the model details are listed here. So it is very much possible that when you launch the Python visualizer.py, you might not hit any problem. However, as soon as you are going to load the PKL file, which is basically a model, you might hit another problem. So there are two sets of problems you would have to fiddle with depending on what you are doing. At this point, if you have interest to learn more about how the visualizer works, I will suggest you to please visit this visualizer guide. This visualizer guide will help you to learn more about how you could use the pre-built models and apply them while you are using any of these pre-built models. If you would want to load this ShapeNet cars model, you can exactly do. Once the model is loaded, you can see the cars related with that models are also visible. Cat model, here is the cat. So this visualizer is divided into three sections: network and the latent, performance and capture, and the layers and channels. So what you are seeing at this point, the latent number 1. If you change this number to 2, you are going to get the different latents. If you would want to see what is really available just to start without even making any change, I will suggest you to just click this animation on And you can also speed this animation depending on, so that's how you can select a particular image if you would want by animating them. If you like something, you can check and uncheck, or you can manually, if you know which latent you are interested to look into, you can change it there. So for example, I can say 20, and that's this particular latent model. So these are the 3D results built into this model. Next, if you mouse hover and you try to move at this area, you will be able to find the 3D render of this latent. If you do not want to see the color image, you can change it there. Here is the normalization as well as the scale of coloring and normalization that can be controlled by here. So reset. Here are the various results coming out from neural networks. So as you could see here, everything starts. So here everything starts from, and as we progress, the different results are available as we grow more and more. After here, we can see that results are improving, and here is your final result. Right now, the look at point is auto detect. However, you can choose depending on which particular data set, what was the look at point. And by looking into the EG3D details, you will find there are different lookout point depending on which data set you are using. Currently, we are using the AFHQ. So it's either you can use auto detect or you can use any of these lookout point. Field of view, like how much size you are looking into. So right now you see that field of view, we can actually reduce this field of view or we can zoom into. So this is the field of view. And here is the condition pose. As you could say, I can change this pose to 1 is changing. I can change here, put it 1. So this is what these are the pose. And as you can see here that these values are being changed from this. If I would want to change this value to 60, you can see that pose values are changed. If you would want to change this pose, you could actually use your mouse or you can change from here. Dragging it, it actually changes the value. Let's select the render. Right now it's RGB. You can actually select the depth image. As you could say that we could change the depth image. So this is how the depth image really look like. And depending on your graphics card, you might see a different clarity. Because my graphics card is little older version, I see a different results here. If we try to change these values, you can see there are little more clarity about it. Reset these values to wherever you would want. Finally, the last one is the neural rendered image. This is how the neural rendered image really look like. Here is the depth sample, and we can also change the latent by dragging this, or I already showed you the animated. If we change back to RGB, you can see the clarity. And style mix is basically if you would want to have more changes, you could actually select these multiple check boxes. And here you could use the truncation, and I think if you use the maximum truncation, the scene fidelity, so you could see that between first and second image from the latent. So if you are enabling this cache backbone, what it does is that it actually keeps the scene identity same, but the rendering parameters, whether it could be the camera pose, field of view, or render type, they can be changed. Now let's load the AFHQ rebalanced model. And depending on our settings, you are seeing really crazy results. So in order to fix this problem, let's go ahead and reset all of our parameters. So once we reset all the parameters, you could see that how this 3D will look like. And if we try to reduce this field of view to little lower, that can also give you a much better detail about the 3D rendering of the given pose. If you would want to change the pose, you can change to 2, you can change to 5. It changes the particular pose available in your model. You can also check the neural rendered field, normalize it. It's just black and white. Scale it out if you would want to adjust it a little better. And if you would want to see the grayscale, you can actually use one of these models. You can also try to find an image which has glasses to see more clarity about the 3D pose which is generated. So let's run the animation. Let's change this to RGB. Looking into this, you could actually see how the glasses are being rendered in this 3D pose. After it, let's take a look at this ShapeNet cars model. Now we can run the animation mode, so we can shuffle through various latent. Looking into color, you can actually match which latent is currently active. Red is 5, go back to 5. That's the pose. So if you end up creating your own model by using your own data set, you can also use this visualizer tool to visualize your results. Let's close it. So the model which we have selected, if we would want to generate the videos based on the selected latent, we can actually use these seed values and we can generate the videos. To use Python, generate videos. Network, our network should be models, and we can use AFHQ rebalanced 128. So that's the model, and it's going to use this seed 0 to 3. So these are the latent. Let's run this code. It's loading this model. So now we have just loaded our AFHQ rebalanced model, and we are passing the 0 to 3 latent, and our objective is to generate a video. So the video is generated in this out folder. So that's our video. We can play it. We have used 2 by 2 grid, and we have used 0, 1, 2, 3, first 4 images. So you could change the seed, and you can also change the grid depending on which video you would want to create. Next, if you would want to just generate the image as well as the shapes, and these shapes will be created as the .mrc file, you can actually use this command. So we are going to use the Python generate samples. We can use, and here shapes true, and our network will be this, and it's going to also generate in this out folder. Here is the seed, and now the MRC file is being generated, and here is our seed. So that's the seed number 1, and here is the MRC. So if you would want to open this MRC file, you would need to download the ChimeraX application, which I already have in my machine. So user bin. So this application can load these MRC files here. So here the MRC file is loaded, and we just need to follow the suggestions provided here. And here is the volume viewer. So in the volume viewer tool, we just need to look into the volume type to surface. So as you could see here, the volume type, we have surface. So step size 1, and the level size 10. So here is the full lightning, and now we can see that how the 3D face is generated for the latent 0. Now we can actually select the latent 1. Let me close this and use the seed equals 1. Here is the face or the latent in the model. Seed 1 MRC file is generated. Now let's launch the ChimeraX. Use this. Here is the model. Let's select 1, level 10, lightning is full. Here you could see that how we are viewing this MRC. Selecting spin movie will generate the movie for this 360-degree view. So we have already generated this movie. So this is the spin movie. You can select various surfaces type. This is how the mesh view really look like. These are the different views. By selecting volume, you can also create the spin movie when the shape is filled by volume type. Okay, so now we can close this viewer. So we have already covered the interactive visualization and how you can use any of these pre-built models. In my next video, where I will be using my own data set with the images provided by me, I will be generating the results, and when this whole exercise will be done, I will be providing a full step-by-step guide so that you can learn how you could use your own images and generate the 3D poses from your own face images or any other image as well. The content covered in this video is located in this DeepWorks repo at this EG3D folder. So that's all I had for you in this video. I hope you have learned something very useful from this video. I am thankful for your time and I'm looking forward to seeing you in my next video. Until then, thank you so much.